Generalized chatbots are too broad to be useful in specific software applications and business scenarios, and off-topic chatbot sessions can mean unnecessary costs and potential abuse. In this video, we'll demonstrate how to combat this by building a custom chatbot that only covers a particular topic. This specialized chatbot will be more suitable for real-world use cases. We will guide you through how to create the necessary logic with Python and LangChain step by step to make this chatbot a reality. Moreover, we're going to add some quick bonus material so you know how to deploy this application for real-world usage. We will employ a simple yet effective approach for the chatbot service deployment on Kubernetes. Additionally, we'll use an open source project called Milvus as a vector database. We're using some powerful open source projects here. Milvus is a robust open source database for vectors and embeddings governed by the Linux Foundation. Likewise, LangChain acts as an abstraction mechanism over LLM models, vector databases, and semantic search functionality, offering great convenience and technology portability. For instance, our chatbot can use flagship models from both OpenAI's GPT-4 and Google's PaLM 2. With the theory now clear, let's go ahead and dive into implementation. For our development work, we'll use the Google Cloud Shell IDE. Once we draft the app's basic logic on a development server in our IDE, we shift to deploying it. Let's start with our front-end code, which incorporates CSS, HTML, and JavaScript in one file. Using a development server will give us an overall idea of the front-end display. Firing up the app locally requires a local vector database. Here, Docker Compose comes into play. This setup is taken directly from the official Milvus documentation. After provisioning Milvus, we will also update our configuration to point at the localhost instance. To ensure we have all the necessary libraries, we'll install them from a requirements file. This includes web application framework packages as well as AI packages. Finally, let's run our application. We'll use the web preview feature of our Cloud Shell IDE to check the front end. The first workflow step is providing some example questions for our chatbot. Our application will use the examples, run a semantic search and vector similarity scoring, and determine if the user's prompts to our chatbot are adequately on topic. Let's look closer at the code that powers this experience. At the top, we have styling, followed by markup for our two interfaces. Within our JavaScript logic, we have three noteworthy functions. First, we have an append message utility function. This function adds messages to the chat interface as we submit prompts and receive responses from our chatbot. Next, we have the send message function, which takes our prompt and sends it to an API endpoint, which we'll walk through momentarily. The function appends the chatbot's response to the chat session for user interaction. Lastly, we have a process.json function, which provides data to the chatbot for determining if subsequent questions are on topic or not. As you experiment with the architecture, you may choose to hardcode some of these examples or even create a separate interface for on-topic and off-topic examples. We've opted to maintain simplicity by keeping everything in the same interface. Moving on to the back end, we have our Flask Python code in an app.py file. To ensure a fresh, clean initialization, we drop on-topic and off-topic Milvus collections, where we store examples and their associated semantic data, before getting started. We also set up our text embeddings API and chat model. The Vertex AI ecosystem from Google Cloud includes both of these AI services. The text embedding API provides a numerical semantic representation of the text, commonly called an embedding. These embeddings are core to the operation of our chatbot and are best stored and analyzed via a vector database like Milvus. Our Flask application has several routes. Requests to the root directory serve the previously discussed index.html file, while requests to the API chatbot endpoint establish or continue a chat session. We use the user's browser to store a session cookie, and that ensures chat sessions continue across separate prompts. Additionally, the API ingests the user's input and calculates similar questions up to 128 nearest neighbor embeddings. We print the closest examples to the prompt for later review. There are several ways to make the decision about how on-topic the user's prompt is. We're providing a simple starting point by summing the squares of the distances across both our on-topic and off-topic examples, but you can, and should, modify the threshold approach based on your own requirements. The final Python function sets up the Milvus data. Since we use the collections in the other API route, we'll make the associated variables global. These collections essentially serve as a knowledge base, using an embedding-based approach to help us distinguish between on-topic and off-topic questions. With LangChain, you should be able to switch out LLMs, text embedding APIs, and vector databases with relative ease. With our code up and running, things are looking good. A natural next step is to test our chatbot front-end running locally in the development environment. Let's picture this scenario. We're a landscaping company with a chatbot on our website. To help us avoid costs for off-topic requests and to mitigate abuse, we're going to teach the chatbot what on-topic landscaping questions look like. These examples include inquiries about gardening tips or landscaping best practices, as well as questions concerning our landscaping services. The flip side is also helpful, so we'll throw in some examples that don't align with our main area of focus, such as inquiries about tax issues or cooking tips. Let's now pose a question to our chatbot. The application logs will help us understand how it arrived at its particular response. For instance, your inquiry might closely resemble the example that talks about shade-tolerant plants for a backyard. Remember, the quality of vector similarity search heavily hinges on the examples you provide, so carefully deduplicate, wrangle, and understand your data. When we look at off-topic examples, like questions about coffee making, plumbing, or even dog training, these have a lower conceptual correlation and thus larger vector distances. Now, when a question deemed off-topic is posed, the chatbot responds in a standard way, implying it does not understand the topic. The demonstrated code and diagram file are available in the video description, so you can reference, reuse, and revise. But let's also quickly see how you can easily deploy this chatbot and build a fully functional software system that isn't just confined to your local laptop. We'll make this happen with Google Kubernetes Engine Autopilot, a serverless method to run Kubernetes applications. We'll have both the Milvus vector database and our chatbot service running on the GKE cluster. We'll set up a custom service account for this service so that with the correct permissions assigned, our request to the text embedding API and LLM chat API powered by Palm 2 will make it through. Next, we'll use sample provisioning code to set up our Kubernetes engine cluster. Once that's ready, we'll install the Milvus vector database, followed by our chatbot service, which will utilize that database. You can find step-by-step instructions on the Milvus website for the Helm installation. After running the Helm installation, we're good to set up our chatbot service. For the service, we'll need to configure a Docker repository and then build and push our image. Following the creation and successful push of the Docker image, we can run our chatbot. If the cluster encounters difficulties pulling the Docker image due to inadequate service account permissions, we'll need to adjust these in the Docker registry. With the permissions corrected, our chatbot should run smoothly. As the chatbot is exposed on a private IP, we need to set up a port forwarding to access the application. Changing the service type to load balancer will make the IP and access public, but you should layer on some security before exposing the application like this. Once our port forward is established, we can test it using the examples created earlier. As before, our chatbot should successfully distinguish between on-topic and off-topic questions. As a part of our AI tutorial series, we're running an AI safety donation program where we donate $1 to the Center for AI Safety for every 10 subscribers from this video. If you found this video helpful, consider helping both the channel and those working on critical AI safety research by subscribing or donating independently. We'll keep an eye on the comment section for any questions. Thanks for watching, and please enjoy responsibly.